height. This is a practice problem using the thin lens equation, power and magnification. It's going to be for a convex lens. And the problem reads, a digital camera whose lens has a focal length of 8 millimeters is used to take a picture of an object 30 centimeters away. There's 3 parts. Part 1, what must be the distance between the lens and the film in this digital camera in order for the image to be in focus on the film? What is the power of the lens? And if the object is 4 centimeters in height, what is the height of the image? How big is it on that film? Now, I said that this was a problem with a convex lens. How do I know that? Well, this is a digital camera, and we need a real image burned onto the film of that digital camera. And the only way to get a real image with a single lens is to use a convex lens. So that's a little bit of a reminder of those conceptual ideas about convex lenses and images and real images and virtual images. So let's write down what we know about this problem and then recap again what the 3 problems are in this problem, and then we'll tackle it. So we are told that the lens has a focal length of 8 millimeters. We're going to put everything into our units, our standard units of meters. So this is 0.008 meters. All right. It also tells us that the object is 30 centimeters away. That's our object distance. That's 30 centimeters. So 0.03 meters. All right. It tells us that the object height is 4 centimeters. So, of course, that's 0.04 centimeters. Meters. Excuse me, 0.04 meters. Okay, 3 parts. Part 1 is what is the image distance? Okay, where's that film have to be to get a good image? Part 2, what is the power of the lens? And part 3, A, B, and 3, part 3 is what is the image height, knowing that I have the object height. Okay, what's the image height? Knowing the object height. All right, so what's the object distance? Well, we can use our thin lens equation to help us solve that. So we know that the thin lens equation tells us that the object distance plus the 1 over the image distance is equal to 1 over the focal length. And I'm interested in that image distance, so I'm going to bring 1 over the object distance to the other side. I get 1 over the focal length minus 1 over the object distance. And now I just plug in my numbers. I have 1 over the image distance is equal to 1 over 0.008 minus 1 over 0.3. That tells me, if I use my calculator, that tells me the 1 over the image distance is 122. I think it's 122.3. Take the inverse of that. My image distance is 0.0082 meters, or 8.2 millimeters. All right, so that's our image distance. Check part A using the thin lens equation. All right, part B is our power, and we know that our power is 1 over the focal length. Well, that's pretty straightforward. We have 1 over 0.008, and 1 over 0.008 is a power of 125 diopters. So just using that power equation. All right, and now our image height. Okay, well, we know that magnification is related to the ratio of the image height over the object height, right? We also know that the magnification is minus the image distance over the object distance. So I can solve for my image height is equal to minus the image distance over the object distance times the height of the object. Oop, I'm going to run out of room. I'm going to erase this part. We'll just put it down here. All right. So my image distance, well, my image distance was given as 0.0082. However, we want to remember our conventions. If the image is on the opposite side of the lens, then the image distance is positive. So we keep that image distance as positive. Okay, so we solve the negative because that's part of the equation, but we didn't want to put in a second negative. So we always want to check our conventions. All right, our object distance we know is 0.3, and that's positive, but also our conventions. And the height of the object is 0.04. So if I chew though into my calculator, we have 0.0082 divided by 0.3 times 0.04. I get an image height of negative 0.0012 meters, or negative, where that 3 came from, negative 1.12 millimeters. So that's my image height. So it's tiny, it's 1.2 millimeters on my film. That's good. We want it to be in that, think about a camera being filmed. What does the negative tells us? Well, the negative tells us it's inverted. Remember, an image height that is negative is inverted relative to the object. Whew, that's good. It should be inverted. We needed the real image, so we should have gotten an inverted height. All right, so using the lens equation, our power equation, our magnification, keeping in mind our conventions for the positives and negatives in that magnification equation. And we're good. Nice work.